Hello everyone. In this video, I'm going to present the debugging process or fixing bugs in Arduino projects or any other robotics projects. So this video is divided into two parts. One will be software issues and another part will be hardware issue. So of course it is correct that when you start the debugging process, we don't know that the issues whether it's related to hardware or software. So let's start it. When we designed robotics, this basically there will be a coding part, a code upload part, and there will be a hardware part where the code is stored and it controls different interfaces, device, sensors, motors, and other microcontroller interfaces or wireless transmission and communication part. So when we start the coding part one, it is done and compilation, everything is done. And during the process of compilation, we generally get the issues where the compilation fails. So in that case, what I have seen is is that the issue is related to the file will be missing or variable will be missing. These are generic errors. So this is my aim to start the discussion from this part. So during this process, sometimes happens is that even if we fix the issue and correct library file is selected for just for the compilation process, it's during the upload process that the code upload fails when you are uploading into Arduino or ESP8266 or any microcontroller related to a tiny systems. So what happens is that what I have seen for this case is that the issue is that the board is not selected correctly, or probably that Arduino RX TX pin is connected and that's why it is not able to access the serial communication part wires, and that's why it fails. These are the basic issues. And sometimes what happens is if you just start Arduino IDE, just come out of the environment, restart it again, recompile it and upload it, it works. This is the basic things. If it doesn't work, then probably you should look for the library. Library is sometimes updated, it is not updated, it's an old file or another version, or probably if you go back to the previous version, it may work. So if I summarize the software issues, the software issue will be related to you have to come out of Arduino IDE, come out and restart again. It should fix the issue. If it is not fixing, then probably change the library file and see if it works. It may fix the issue also. And even if the code is uploaded, probably it will not be working as expected actually. In that case, you may have to look for another library file and recompile and upload it. So this is the compilation part and working with the Arduino IDE. There will be many more issues probably, so that we have to look for while it comes. So these are the very generic issues we we encounter while working with Arduino IDE. And this, as you know, Arduino IDE, we can work with ESP, we can work with Teensy, we can work with Raspberry Pi, Pico 0, you can work for ESP8266 and many boards related to other microcontroller also. We can work with ARM controllers, microcontrollers. So those are the basic things related to the fixing. So the compilation part and upload part can be fixed most of the time. The upload fails because the board is not correctly selected or the port is not correctly selected. And probably what happens is if the communication wires USB cable is not properly, it is loose somewhere, or probably connection is not proper. So in that case, it can fail. So you have to just disconnect, reconnect it back. Make sure that RX and TX pin is not occupied and is not connected to Arduino. So this is only case of Arduino issues, Arduino board microcontrollers. So these are the issues related to upload part. And once it is uploaded, what happens is if it may not work also. So we have to see this software part. Once the software part has been taken care and they expected that it is not performing as expected, then we have to look for the interfaces connected to the Arduino. So let look for the typical issue we encounter when everything else other than the hardware part has been fixed and it is properly working. So this is one Arduino, and there is a relay board here. So what happens is, in case of Arduino board, generally most of us, we directly connect to, we use jumper wires. These are the jumper wires. We directly connected to this Arduino pins here. And what happens is, jumper wires are not really very reliable. So you will get the connection will not be proper, or probably these wires, jumper wire, will be internally broken, or maybe there is a component formation and that's why the connection is not proper. So the physical connection is missing. So you will not know, because if you touch the wire, it may start working and suddenly after some time it may not work actually. And sometimes what happens, we use plastic breadboards. So those boards are also not very reliable. So we have to see that for fixing hardware issues, we have to see that first the connections are proper in case of Arduino pins here. To make it proper, what we can do is, we can make these connections like this, solder the pin directly, and then you have to solder and make sure that interface is proper. What some people do, they do is they remove the pins, the female pins here, and they directly solder the wire into Arduino. I'll not advise those kind of connections, because what will happen is that you cannot take out this board and reuse for another project. So it's up to you. If you have additional boards, you can take out this, directly solder the wires here, and it should work properly. So this will be very reliable, and this the project will last for a long time also, and you can just switch on and the project will start working. So this will be the main. So look for workflow. If you are using breadboard, try to replace the breadboard. If you are directly connecting to Arduino boards, make sure that it's replace the jumper wires. Jumper wire also, if you are really want a very secured and reliable connection, then make sure that you create something like that, solder the pin directly and solder the connection interface wires connected directly here. So in one case I have done this for my projects. And this is that in case of ESP. So what I have done is, I have directly soldered this wire here. I have directly soldered this for an additional soldering here. So this is ESP part here. And in case of Arduino Pro Mini, we make sure that this is Pro Mini 3.3 volt. Make sure that you directly make some kind of adapter and with female pins, and try to connect this directly and use additional soldering pins directly to connect the wires and cables to the board, additional board. So this will be the connection part in case there is issue with the proper connection, the physical proper physical connection. If you see here, even for the relays, what I have done is I have directly soldered here additional pins here, and the actual connection can be soldered at this part. So this will be very reliable. We don't have to connect the jumper wires, and the jumper wire will get loose after some time and may stop working after some time. So this will be this will avoid most of the issues related to the hardware part. Now coming to the powering of the board, microcontroller projects. So there will be options where the project will be either the robotics project will be mobile, or it may be a static at a place. So a project related to if it is mobile, then probably we have to power it through a battery, a lithium ion battery. and if it is static at a place, we can use a AC to DC converter and power the project. In case of that, we have to look for a proper adapter model, power model. This is AC to DC. This is AC to 220 to 12 volt and 2 ampere. So I'm using this to power my stationary project, robotics project. And as you know, in case of Arduino, Arduino, most of the Arduino boards, we can power through barrel jack. We can power through, there is a 5 volt option here. We can power through that option also. So make sure that you always power the Arduino board, Arduino Uno board or any Arduino board through 12 volt. I mean more than 12 volt, it ranges between 12 to 15 volt, which is the proper voltage rating for Arduino boards. So this is a way you power it. If it is more than 15 volt, then use a regulator to bring down the voltage and power through barrel jack. So that way you'll get help, you'll have proper voltage and proper current for supplying to the pins and any additional devices you are interfacing to the board. If you are powering through 5 volt here pin, there is another pin here, then make sure that it is, this what I have seen is that it doesn't work properly. It not be able to power the board properly. In some of the voltage may drop, may be there somewhere, or the current supply will not be proper. It may not work actually, and you will not be able to find the issue related to the project. It may, if there is a Bluetooth connected here in RxTXP, it may not work properly. Although the things will look proper, but it may not work. So, and if you are powering a sensor directly through this 5 volt, it may not work properly. So make sure that you power the Arduino board separately with 12 volt, and then use another regulator to bring down the voltage to 5 volt and power your additional devices which require either 12 volt or 5 volt supply. So this is for Arduino board. If you are using a Pro Mini, this is Pro Mini, there is a input raw voltage here which you can power through 5 volt supply, 12 volt supply, and then it will bring down the voltage depending on it's a 3.3 volt or 5 voltage supply. So don't power it directly to 3.3 because it will not be enough for proper voltage and current supply. So always put a raw voltage here which will bring down the voltage, and then it should work properly. In case of ESP you can only input 5 volts. So you have to use a regulator and then you power through 5 volt. Don't power through 3.3 volt because there will be a further drop in the voltage somewhere in between, and it may not work properly. Although it may work may look proper, but it may not work actually. There will be some drop in the current, some drop, something else will happen, and it will be very difficult to fix the issue. So make sure that it is powered through 5 volt here. There is a range here, and most of the ESP they take 5 volt input and then internally they bring down to 3.3 voltage. So this is what we should remember. Make sure that the input voltage and wires are soldered directly to the board or through adapter pins they are soldered, and this is just attached to the adapter. So that way all the connection will be proper and there will not be any loose connection. That will make sure that the project is working fine. So we have talked about finding the issue related to jumper wire. We have spoken about the voltage supply, power supply for the projects. In case of the most of the microcontroller project, you know that they take input as 12 to 15 volt or 18 volt, and there's most of the ESP and those things they take 3.3 volt and 5 volt input. So they'll internally bring down 5. There is separate pin for raw voltage and separate pin for proper exact voltage rating. So these are the main issue. In case of other things, make sure that coming to the third point, sometimes what happens is that we unknowingly destroy the board by connecting or reversing the polarity. So to deal with that situation, what we can do is use a diode before connecting the raw voltage or any voltage to the board. So if it is 12 volt, use a proper diode with a proper rating. There will be some drop in the voltage, but still it will take care of the proper voltage. And that way you can avoid the polarity reversal. If the polarity is reversed, it will not work. So it will at least avoid the destruction of the board. So always make sure that in case of ESP, because it's very sensitive to voltage fluctuation and will burn the board actually. So this is a must for ESP. Even for Arduino you can use. So, and even for Pro Mini you can use it. There will be some drop, but that is okay actually. So this is, you can take care of polarity reversal issues. So you'll at least avoid the costly board before they get burned. In case of interfaces, make sure that you directly solder the wires, jumper wire directly to the board by removing the female pin or male pins connection part. Cut it down and then directly do it. If you are soldering, in case of this, if you see here, I have soldered here. Make sure that the soldering is proper, because sometimes what happens is that we solder it, they look proper, but internally they are not soldered properly. And just if you touch it or scratch it, they will fall off. So what happens is those kind of project will stop working after probably a week or two or sometime later. So make sure that you solder it and then try to clean every part, so that way it looks like if there is any pseudo soldering, you'll find out and you can re-solder it back before you start struggling why it is not working. Everything looks fine, code is fine, upload was fine, interfaces look fine, and then do it. So this is so as you can see, we have spoken about code writing, fixing the compilation part, code upload into the board, microcontroller board, fixing the hardware problems. Now coming to additional things, not remembering, yeah, if you are using AC supply are dangerous part. So make sure that, because most of the, if you see AC modules, they have all this pins are visible actually, they are open. So if you by chance touch it, you will get a big shock. To avoid this, because this is not proper model I am using, so what I have done is I am using Krypton tape to cover it, and internally I'll just cover it so that I don't touch it before I start using. So make sure that you do that, and what you can do is even cover with a plastic material so that you don't touch it unknowingly and you get a shock. This is one thing. These are some of the issues we encounter while designing robotics project. Another thing is that when you're designing a very complex project, suppose where there is involvement of motion sensors, there is a involvement of wireless communication, transmission, those things, make sure that you test separately each of the project, because sometimes what happens is that this servo motor will not work with RX transmission. So you may have to use a separate microcontroller just to control the servos, and later you connect it through Bluetooth through this what is that we call I2C connection or any other connections, or through RxTXEs, and pass the data to another board and make sure the other one also gets the communication and they work with each other in synchronization. So that we have to see, because there might be conflict and you may not be able to work. Suppose you are using two Bluetooth, to make sure that this works. First you make sure that both are working separately, and then you combine them and then you work. If you are transmitting data to another mode, then you make sure that transmission happens before you start working with the actual project. If you are using sensor, motion sensor, then you make sure that you are receiving the proper data, and then your whatever manipulation you are doing internally inside the microcontroller, and you are sending that data to another the motherboard, the parent robotics module, and it receives properly before you start using that data. So this has to be done separately, each one has to be done. And if you are using more than one interfaces like motion sensor, Bluetooth and other things, plus additionally you are using ESP also, then make sure that each one works separately before you start combining each of them into groups, and each one is working separately. So this we have to take care of those points, otherwise they will not work. I am going to show here two things which I have done for myself, and probably you can see if it works for you. So this is one of my robotics project. So as you can see here, this is this I have used two Bluetooth, one Bluetooth, this second Bluetooth, this is ESP also. So ESP, what I was doing is sending, you can control this robot through a web page also, you can directly control, there are 3 designs for this one. You can control this from a phone, as well as you can there is a remote controller also, that also which is based on buttons. And this is the main board. So the ESP and the UNO is connected, and this other 2 Bluetooth are also connected to this UNO boards. So each one is separately connected. And each one I tested before I connected all together at the same time. So there is, what happens is sometimes they get slowed down because of the entire communication part happening. So if you remove probably one board, it may start working. So the speed will be normal and it will look proper, functioning will be also be there. So this we have to make sure that, and also if you see I have soldered all the things, and supplying through barrel jack. So this is one thing. I have another design here which I am not showing here, but that is also based on a servo is controlled through a separate board, because when I try to control through RX transmitter and servo controller was not working in sync, because there is some kind of conflicts happening. So that was also resolved by using another controller, and where these 2 controllers connected through IC2 pin, and they started working. So this is another problem, because the conflict will come because internally this some conflicts will be there. So you have to try all the combination before you start working. So that way you will be able to debug the issues. So hope this helps, and if you need any question, any help, let me know. Thank you very much for watching this video. Bye bye.